Hey guys, let's discuss new problem from Trie data structure, which is called, we will discuss few functions here. For example, count starts with, or count words starting with, okay? Count words equal to count word starting with insert and erase function. So in the earlier video, we have already discussed insert, search and starts with three functions, right? Now here, let's discuss these new functions. But here, you have to insert, what you need to do, first you have to insert three strings into the trie. For example, apple, apple and app. Okay, these three strings you will insert into the trie, and then you will count the number of words equal to apple. Okay, after that you will count number of words starting with app, and then you will erase one apple string. Okay, after that again you will count the number of words equal to and number of words starting with app. So this is very simple. Here just a small change in the earlier trie. You will take two integers, okay, prefix count and word count. So prefix count we will be incrementing after each word insertion, okay, and word count we will be incrementing once your one string insertion is completed. That time we will just increment word count because one word is completed, right? Then only. So let's dry run this. Okay, how you will do this? So very simple. Let's see. You have this root node. Okay, initially nothing, this is empty. You have a children array of size 26. Okay, 26 represents the alphabet, 26 alphabets, and 0 will represent for A, index for A, and 25 will represent index for Z, and then you know the between indexes. Okay, so initially you need to insert apple. What will happen? You will go and check to this root node, okay, in this 26 size array. So app A represents 0th index, so children of 0. Is it null? Yes, it is null. You don't have element there. So what you will do? You will create one trie node, okay, you will add A there, and it's a reference you will add here in this array, okay. And then what will be the value of prefix count and word count? So prefix count will become 1 because one prefix added, okay, one character added. So after each character you will increment the value of prefix count, and after each insertion of the string you will add the word count counter. So 1, 0, word count is 0, right? Then it's time for P. So again you will insert P. You don't have P here in the trie, so you will insert P, and then prefix count will become 1 again for this node, right? And then word count will be 0. This one will not be 2. We are not referencing. So this node has its own prefix count. This node has its own prefix count, and same for word count also. Okay, now again it's time for P. So P will come here 1, 0 again P. Then it's time for L. L will come here 1, 0. Then it's time for E. APPLE. So 1, 1 because you will increment the value of word count. Okay, so this apple is done. Another apple will come APPLE. Okay, so you will come here at A location, so it is not empty, so you will go to that reference. So you have A here, so that is fine. We don't need to create new node, but it's a prefix count will get incremented, so it will become 2 now. Okay, word count, let it be like that. So again for P, again you got the P, and then you will increment its prefix count, then here also, and here also, and once you reach at the end, so this one will also become 2. Okay, now it's time for third string APP. So A will come here, so prefix count will be 3. Okay, prefix count plus plus here also and here also, and then word count will become 1 here because APP is done, right? Now if someone will ask you what is the count words equal to apple, so you will traverse apple, okay, APPLE, and whatever word count it is, it has in that node, just return that. So answer will be this one will become APP. Okay, so you have system.out, yeah, okay, this one, now we are talking about this one. So word count 2, so 2 will be your answer. Okay, now count words starting with APP, so you traverse APP. Now it is saying starting with and not the equal to, so starting with means at least 3 strings are there which is starting from APP, right? So the answer will be 3. Now you will erase apple. So how you will erase it? Nothing, you just go to A. Okay, you got A, so you will decrement its a prefix count, and then once the string is completed, so decrement the word count also. Okay, so this one was 3, 3, 3, right? So this one will become 3 decrement, so 2 will come here, 2, 2, 2. Okay, this one will become 1, this one will become 1. Now again and this one will become apple, no? So this one will become 1. Okay, now again someone will ask you what is the count words equal to apple, so it is 1, so you will answer 1. Okay, and count words starting with app, APP starting with app is 2 because you have erased the one apple, no? That's why. So this one will be your answer. Now let's check what is happening in the code. So we have already discussed the structure of trie node. You will take one children array of size 26, and then 2 integers, prefix count and word count. Then this one is your main also we check. Okay, let's see what is happening here in in insert function. So insert function, you would be given one string word, okay, and you will take one root node, the initial node, this one is your root node, okay, and then what you will do, you will convert that word into character array, and one by one you will pick one character, okay, and you will subtract small a from it, so that you will get the value 0th index, means 0 1 2 3, this kind of index value, okay. So now you will check if node ka children index is equal to null. See, if you don't have value there, then you will add one node, okay. You don't have there, first time you don't have, so you will add new try node there, okay, and then in node dot children dot index you will put in node, okay, and node ka prefix count plus plus, and you will run this for loop for entire string, and once the string completed you will do node dot word count plus plus, okay. Now what is happening in node count, node word equal to what you will do, you will again get that word, okay, you will traverse that word to entire try node, and then you will check if node ka children index is equal to null, it means 0, means you don't have that string there, so at first time only just return 0, okay, when you don't find it. Otherwise node equal to node children next, like in tree we were doing left, node equal to node ka left, right, you need to go into left subtree, so you do node ka left. When you need to go to right subtree, you were doing node ka right. But here from one node, see, from here, from one node to another node you need to jump on. So how you will jump, you will go to its character array, and whatever reference is there you will go to that reference, right. So how you will write that, node dot children index, okay. So node dot children index you will go, and then you will iterate this for entire words, and then you will return, at the end you will return the prefix count, okay. Same will happen for the word count, means in erase, so see this one word count, and same will happen for the prefix count. So this two done. Now if you wanted to erase something, again you will traverse that tree and just do prefix count minus minus after each character, and word count minus minus after each word completion, right. So here you are doing, instead of plus you are doing minus 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 minus, that's it. So this is the function, and this is how we work with try. So thank you.